Hello ladies and gentlemen, and welcome back to another AP Environmental Science screencast with your teacher, Mr. Stano. And today we're going to start talking about dams and other water transfer type projects. So let's get into dams first. Basically, dams themselves provide a number of benefits to us, one of them holding back water that we can use for a number of different reasons that we'll go into in a little bit. They also can provide cheap electricity through the use of hydroelectric power. They can reduce downstream flooding because they control the amount of water that's moving through the stream. The water can be used year-round for irrigation, but there are a number of smaller issues or larger issues depending on the population size in the area. So a typical dam itself has a number of different components. We have the reservoir that's behind the dam, the intake where water goes in. It'll travel down through the penstock. Goes through the penstock where it encounters a turbine. This turbine is then connected to a generator, and this generator will then produce electricity and go out. Water leaves through, exits the dam, and then continues downstream. That is the basic anatomy of a dam. There's not much really to it. So here are some of the, this is looking at a dam, a little bit of a larger picture, and this is some of the benefits that it provides for us. Much of the same things that we see with groundwater, so irrigation for us year-round, water for us to drink or residential use, the cheaper power, all important stuff. These bigger issues that we see, though. Definitely hampers the migration of some spawning fish moving through that are moving upstream. So we have the use of fish ladders, which we talked about in the last unit, to kind of get the fish to come up and around. So we can fix that. Not the best solution, but it does work a little bit. If there is a failure with the dam, then all of a sudden we're going to have a huge amount of water moving downstream pretty quickly. We have downstream cropland naturally deprived of nutrient-rich silt. What ends up happening is as the water comes and the dam blocks it up, you're going to have a buildup of silt behind this dam. Silt that would normally travel downstream. It's not there any now. That those nutrients that are carried can end up, typically would be used for cropland and a number of different uses. It's not there now. We also see large losses of water through evaporation. Because this water's here now, it's going to evaporate into the atmosphere. But one of the biggest issues that we see is the flooding of everywhere behind here. So this whole area has now been flooded. So it destroys a number of habitat and people living in these areas getting displaced. So these are a number of issues that we do see. The Endangered Species Act can come into play with some of these. The Scenic Rivers Act also can come into play. So there's a lot of regulation on them where they can be built depending on if there's endangered species in the area, if it does fall under that scenic river. So there are things, they can't just be put up everywhere, but there's usually sometimes a little bit of workaround in the project that is needed or pushed. It's a potential that it may go through. The Colorado River Basin here in the United States is an area where we have a large number of dams built along it, and ended up having is reducing flow as we go through that river. So you can see you have 14 major dams, and in the next picture you can see how they're set up. It does provide electricity, but the issue is that the river itself has less and less potential as we move through. Lake Powell, where we see one of the largest reservoirs in the United States, also has one of the hydroelectric power plant on it. And you can see it here in this image. So here it is, Lake Powell, all behind here. There's a dam holding back the water. And this is these dams that are set up on the Colorado River. So you can see starting all the way up here towards Wyoming and upper Colorado, we have a dam here. And what it ends up doing is we're reducing downstream flow here. So another one's got to go up and keep going. And more and more municipalities have to put up dams to make sure they have the water supply that they need. By the time we get to the Gulf of California, the Colorado River is basically non-existent. So there are an issue with that. We have China's Three Gorges Dam, which is built within the past few years. Massive dam, about 2 kilometers long. A huge amount of electrical generation produced from it. Helps ship travel. It did displace about 1 million people from the area. And the area that it's in is a little seismically active. Not much, but just enough to cause some concern. So there was a pretty massive debate over this dam. ultimately, it was built. There's pretty much nothing to be done now, but it's a huge, huge dam. The undertaking of building the dam. Dam removal. Occasionally, we can remove dams for any number of reasons, and such as it may be something falling under the Endangered Species Act, but they can be removed. Or if at some point maybe that they're no longer useful, we can remove them. So Army Corps of Engineers could be in charge of some of these projects, and will pretty much help with the removal of those. Another issue that was mentioned in class is water transfer projects. So basically moving water from one area using a series of pipelines, aqueducts, whatever the case it may be, and moving it to an area where the water is needed. And this we saw with California, and we were talking about it in class with a number of with moving water from Northern California into areas in Southern California. So it's been a plan on the works for a while, and kind of nothing's really happening with it yet. We have the endangered species up in this region for agriculture down here. So there's a number of issues, and pretty much nothing is really going on with it at this point. The Aral Sea, massive disaster right here. We're looking at the fourth largest freshwater lake at the time, in its heyday, I guess you could say. And then Russia came in, diverted water from it through a number of different rivers, and now it's the size that we see here. So it's definitely shrunk considerably with the water diversion for agriculture. So we wanted, the Russians wanted to grow something in an area, I believe it was cotton, that was not meant to be grown there. So they had to divert a huge amount of water, and we saw a lot of, besides the sinking, the disappearing of the sea or shrinking of it, we saw a number of ecological effects from it too. There's other ways we can get the fresh water. So besides transferring dams, groundwater, we could take the salt out of water through distillation or desalination or reverse osmosis. In either situation, is removing salt from seawater. The issue is that it uses a huge amount of energy to do. So if you have the energy, it's fine, but typically we're looking at areas that may not necessarily have that energy, so it's not really the best thing to do. It also will leave a salty brine solution behind, and that can, we're looking at pretty high salinities, and that could definitely affect local ecology and habitat. So another issue is possibly with seeding clouds, kind of like a little bit of a dream, but if we seed clouds, then we can get rainfall to happen in certain areas. It's thought of as allegedly there was a little bit of work done with it, but how practical it may be, not really sure. One of the best things we could do, though, is water efficiency. Basically, we can conserve and use water less, or make whatever processes we have more efficient, so we keep whatever water we have to around, and it really doesn't, there's no big cost usually associated with it. Usually it's a win-win situation for the people involved with developing the efficiency standards and the people using themselves. So it's pretty much one of our best options. Or government subsidies for water efficiency can help promote that industry. So there's a lot of things we could do. Leaks are a huge area where we see a lot of waste. So within the city, they're older in their water infrastructure. As basically time goes on, it degrades, and we lose a lot of water through leaks. You can see this in your own house too. The toilet bowls eventually will leak water from the top tank to the bottom, faucet stripping, or leaky pipes within a house. So these are all things that we can remedy to help conserve water, sometimes relatively cheaply. Irrigation water, like we said, is a huge amount of use with worldwide use. About 70% of worldwide freshwater use, or if we go to your United States, looking at about 45 to 50% of the water. So there are ways to more efficiently water our crops besides what's out there. One of the best options we have is center pivot low pressure sprinklers. And this basically will put water directly to the ground. The water goes directly to the ground, so there's less evaporation, and it's used more efficiently versus a typical sprinkler where you see it spraying up into the air. Those fine droplets evaporate relatively easily, and that water can be lost. These are just different methods right here. We have for irrigation. So you can see the number we have. So we have the gravity flow right here. I don't think it's really the best. We do see it occasionally, but drip irrigation, definitely on a residential level, is quite doable, and we do see it on a commercial level where these pipes go out, they have little holes in the pipes, and they drip water directly onto the ground. So it's reaching the target plant, highly efficient, very little evaporation, and then here's our center pivot. Now typically with these center pivot, you'll also see it'll have a combined drip irrigation. So you'll see a little pipe attached, it goes directly, it lays directly on the ground, and as this rotates around, it places water directly onto it. So center pivot low pressure can be modified with like a drip irrigation to become even more efficient. So reducing irrigation water waste. So there's a number of different things. Leveling fields with lasers, so we can get the water directly into those. Lining canals with some sort of liner, so that water is not lost in the movement or the transfer, but only to where we want it. Polyculture, growing many different crops in an area, plants that use water at different times will reduce need. Organic farming, don't grow water-thirsty crops. It's one of the best things. Don't grow crops in an area that it typically wouldn't grow in. Or irrigate treated urban wastewater, gray water. It can be done at home. We see Israel uses a huge amount of their gray water. It's do whatever you can to save and conserve whatever water you have. There are areas in lower tech approaches or countries that don't necessarily have the money that are able to still get water. So we can see here this pump device. It's human powered, and this woman's able to basically bring water into her crops. Do what you have to do with what you have. So reducing water waste. Basically, we look at a lot of efficiency standards. So we're basically redesigning manufacturing processes. So we're using less water or making use of older water. Gray water. Use water meters. Some areas of the country don't meter their water, so no one knows how much they're actually using. Using drip irrigation. Raise water prices. If it becomes more expensive, people will use less. Purify and reuse water, like I mentioned. So there's a number of different issues, things that we could do to reduce our water waste. Raising the price of water is definitely one thing that most people would not like to do, but it definitely would decrease the amount of water that's wasted. Using less water to remove industrial and household wastes. There are a number of different things here. So using less water, or taking that water that has been used in industrial processes and converting it to something that is more useful. So we can mimic the way nature deals with waste. Instead of using large amounts of high quality water, wash away and dilute industrial and animal waste. So use waterless and odorless composting toilets, which we have talked about before, that convert human fecal matter into a small amount of soil material. We'll be more on that soon enough. And use nutrients and wastewater before treatment as soil fertilizer. Too much water. Now, we have been talking about California, who's been a massive drought, just received a huge amount of rainfall. So what happens? Well, we definitely see some flooding. Landslides that we've also been seeing because now the ground's a little bit more unstable and dried out. So these are a number of things that can usually happen within these areas. So too much water, not necessarily the best thing in the world, especially when you're in drought. Okay, here we're looking at St. Louis in Missouri, look under normal conditions, and then basically if there's severe flooding. So like I mentioned, too much water, not necessarily a good thing, and especially what we have done with our landscape, basically at the point where we've destabilized it. How? By removing trees and plants that would hold on or help hold that soil in place. Now it rains and it's able to move, like you can see in this right-hand picture. Very similar to what's happening in California right now. Versus on this left-hand diagram, where we have our trees in place. So not only does it provide habitat, it basically stabilizes this area right here. The leaf litter improves soil fertility, which we see here in the Northeast. The trees also reduce soil erosion besides looking at those heavier landslides. So there's definitely a number of issues with too much water and how we've changed one landscape into another. So reducing flood damage. Basically, what we want to do is preserve our watersheds, keep those trees in place to help stabilize our landscape. Tactile development on floodplains. We want to make sure that they're in good working order. and that people are not developing in these areas that are have the ability to get flooded quite easily. Build levees or flood walls along streams to control and move that water. And basically, we could build dams, and that would also regulate how much water is moving downstream. Okay, so what we can do to use water more sustainably at home, like I said, some simple things: stopping water leaks, flushing toilets only when necessary, using gray water for lawn. We'll talk more about that in class. Gardens, houseplants, and car washing. Use commercial car wash. Try to find one that recycles its water. I mean, there's things that we could do at home to help us conserve water. You guys at home, basically you can only water every other day, water your lawn every other day, otherwise you incur a fine. I think it's like anywhere from $50 to $75. So it's quite a bit, that's even done on a municipality level to help us conserve water. And that's about it. Hope you enjoyed this screencast. Do what you can to save your water and enjoy it. Take care.